In this video, we'll learn how to calculate the total CFM in a section of ductwork or moving across a coil or other piece of equipment. Then we'll learn what happens to velocity when we try to reduce our ductwork without reducing our CFM. Here is the formula that is used to calculate CFM or velocity. CFM, which is cubic feet per minute, equals velocity, which is shown in feet per minute, multiplied by the area, which is shown in square feet. A cubic feet of air is a slice of air 1 foot by 1 foot by 1 foot deep, which might look like this cube. For example, to determine how many CFM were flowing through a duct section, we can do the following. First, we would measure the width and height of the duct. Let's say it was 36 inches by 24 inches. Next, we could use some form of anemometer to get an average velocity reading across the duct section. Let's say the velocity reading is 450 feet per minute. Now we can solve for the quantity of CFM flowing through the section of ductwork using the following formula. CFM equals 450 feet per minute times the area, which is 36 by 24. We'll need to convert our duct dimensions in inches into square feet because we are looking to arrive at cubic feet per minute. 36 inch by 24 inch equals 864 square inches. 864 square inches divided by 144 square inches per square foot gives us 6 square feet. Now we can enter the total square feet into our formula. CFM equals 450 feet per minute times 6 square feet equals 2,700 CFM. Now we can use another version of this formula to calculate for velocity when the CFM and area are known. Solving for velocity. For recommended velocities in ductwork, see ASHRAE's Handbook of Fundamentals. Depending on the noise criteria and where the duct is located, the velocity for rectangular duct could be from 950 to 3,500 feet per minute. Remember, this chart shows maximum airflow velocity. The velocity is often much lower than these maximums. What happens to the velocity if you reduce the size of the ductwork with the same CFM? Let's say that we reduce the ductwork to 36 inches by 12 inches in order to get under a beam. The approximate velocity can be calculated with the same formula, except this time we'll keep the CFM constant and not worry about static pressure or other factors that may affect the outcome slightly. Velocity equals CFM, cubic feet, divided by area, square feet, taking the known values of 2,700 CFM and the new duct area of 36 inches by 12 inches, we can find the new velocity. First, the duct area needs to be converted to square feet. 36 inches by 12 inches equals 432 square inches. 432 square inches divided by 142 square inches per square feet equals 3 square feet. The new duct is half the area of the previous duct size, but it is carrying the same CFM. So what happens to the velocity going through the reduced duct size in relationship to the previous velocity? Our velocity was at 450 feet per minute. Now with the same CFM, but a smaller duct, we get 900 feet per minute. Velocity equals 2,700 CFM divided by 3 square feet equals 900 feet per minute. The ductwork area was cut in half from 6 feet to 3 square feet, but the velocity doubled from 450 feet per minute to 900 feet per minute. You can see there is a direct correlation between CFM and velocity when the size of the duct or coil is changed. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.